All have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about different types of MOSFETs. So basically MOSFETs are classified as enhancement and depletion modes, and under enhancement mode we have p-channel enhancement mode and n-channel enhancement mode, and in depletion mode also we have p-channel depletion mode and n-channel depletion mode. So enhancement type MOSFET, in this type of MOSFET no channel is present from the beginning and hence no current will flow. But when the positive voltage more than the threshold voltage is applied, it leads to an enhancement of a channel between the drain and source due to the gate voltage, and thus it results in the conductivity of the device. They are mostly used in digital applications. So in the depletion type MOSFET, the channel is present from the beginning, which means conduction of the current is there. Negative voltage is applied to reduce the flow between current, and this reduces the width of the channel, and it is not used commonly in devices. So next we will see the characteristics of MOSFET. So MOSFET have majorly two characteristics: drain characteristics and transfer characteristics. So in drain characteristics, it is the characteristics between the output current and the output voltage. So the output current is given by ID, output voltage is given by VDS, and the control variable here is the VGS. So a graph will be plotted between ID and VDS for various levels of VGS. So in the case 1, when the VGS is greater than the threshold voltage VT, so the effective voltage will be VGS1 minus VT. So it will directly affect the width of the N channel, and significant amount of the drain current will flow through it. When VDS is increased to a certain level, drain current becomes constant, and this is called as the pinch off condition. So under this condition, VDS plus VGD minus VGS is equal to 0, which implies VGD is equal to VGS minus VDS, which is the pinch off voltage VT. In the case 2, VGS1 will be greater than VGS2. So the conductivity of 1 will be greater than conductivity of 2, which implies R2 is greater than R1, and the slope of 2 will be greater than the slope of 1. So here few regions will be there: saturation, triode, and cutoff region. So saturation region is the region in which the drain current is constant, and the triode region, left area of the locus of VDS saturation, and cutoff region is when it can't achieve the threshold voltage, MOSFET remains off, the current will be 0 amps. So this is shown in the diagram. So this is the drain characteristics. So here with increasing voltage, current flowing through the terminals increases with the voltage. So you can see this is the graph. VGS more than the threshold voltage is the condition of flowing current. So next one is the transfer characteristics. It is the characteristics between the output current and the input voltage. So for both for enhancement type and depletion type, here it is shown. The left side is the enhancement type and the right side is the depletion type. So when the value of the voltage across the gate and the source is less than the threshold voltage, V is equal to VT. So working of N-channel enhancement type MOSFET. So the symbol also is shown here. So in such kind of MOSFET, we have to make gate terminal more positive. Hence positive charges will accumulate in the gate and will attract negative charges in the body. So electrons will be drifted towards the surface, and the region near the surface will become less p-type. Positive charges are pushed down, so above region will become n-type, and thus the channel is formed. If we increase the voltage between the gate and the source, then the width of the channel will increase, and if the voltage is more than a particular voltage, the channel width is sufficient to allow flow of current, and this particular voltage is called as the threshold voltage, and the resultant current is known as the drain current. So next we will see the working of a p-channel enhancement type MOSFET. A p-channel enhancement type MOSFET is a type of MOSFET which works by applying positive voltage to the device. So it operates according to the voltage applied to the gate terminal. Hence the flow of current occurs between drain and source So it has mainly three terminals, source, drain and gate. It forms a semiconductor substrate. MOSFET has a thin insulating layer of oxide in it to separate it from the semiconductor. The source and drain terminals are made with P-type semiconductor, and so is the enhancement channel. In a P-channel MOSFET, majority charge carriers are the holes. It is generally off when no voltage is applied. On applying voltage, it creates an electric field in the oxide layer, and hence a channel is formed by the movement of holes. Then current starts flowing in the channel between the drain and the source. Substrate or body terminal is made up of the N-type semiconductor. Current in the channel can be controlled by the gate voltage. So the figure shows the P-channel enhancement type MOSFET and its symbol. So next one is the working of N-channel depletion type MOSFET. So here the symbol and the diagram is shown. So in this type of MOSFET, three terminals of present, drain, source and the gate. Same as the other MOSFET, it also contains a thin insulating layer made up of gate oxide to avoid direct contact with the metal. Here channel is present from the beginning. By applying a positive voltage, it creates a depletion region, reducing the charge carriers and results in the decrement of the current. MOSFET is generally on. Drain and source terminal is made up of the N-type semiconductor. So next one is the working of a P-channel depletion type MOSFET, whose symbol is shown here. So similar to the other MOSFETs, there are mainly three terminals here, gate, source and the drain. The current between the drain and the source is controlled by the gate voltage, but there is a difference. Channel is present from the beginning when no voltage is applied. Source and the drain terminals are made with P-type semiconductor, and so it is the channel. Majority charge carriers are the holes. Applying a negative voltage, the channel depletes, and hence the width of the channel decreases, and hence the resistance increases, decreasing the amount of current flowing. So it is a voltage controlled resistor. So to see the differences between enhancement and depletion type MOSFET. So first, in the enhancement type MOSFET, by applying the external voltage in the channel, if the amount of the charge carriers increases, it is known as enhancement type. When applying an external voltage, if the amount of the charge carriers decreases, then it is depletion type. So no channel is present in the beginning in the enhancement, channel is present from the beginning in the depletion. There is a threshold voltage in the enhancement, there is no such threshold voltage in the depletion. It does not produce current in the absence of VGS for enhancement, and it will produce the current in the depletion type. Let us take up some assessment questions. If a MOSFET is to be used in the making of an amplifier, then it must work in saturation region. For MOSFET is to be used as a switch, then it must operate in both cutoff and triode region can be used. In the saturation region of the MOSFET, the saturation current is independent of the voltage difference between the source and the drain. Thank you for watching this video.